and other very important property known as the stability. We have the data for this quantity with respect to the binder content, which I am going to tabulate over here. 1650, 1760, 1870, 1950, 1850, and 1780. Its unit is kilogram into weight. Now, this is the data for this stability. This is the data of the binder content with respect to which this stability has been determined. And this stability is determined by the Marshall compaction machine. Okay. This data is taken from the Marshall specimen. Using that data, we are going to study this, so that which stability is acceptable to us. Now over here, as usual, we will draw the graph between these two quantities, 2, 2.5, 3, 3.5, 4, 4.5 and 5. This is the amount of the PB. Over here, 1600, 1650, 1700, 1750, 1800, 1850, 1900, 1950. This is the stability value. Now, this data will be plotted over here. Then we will say what is the behavior. With this 2.5, it's at this point. With this 3, it's at this point. With this 3.5, 1870, at this point. With 4%, 1950. With 4.5%, 1850. And with 1760. It's like this. When we are going to join these points, we are going to get curve like this one. Here I would like to tell you one thing. With the increase of the binder content, stability is increasing. When it reaches to the certain point and then stability is dipping downward. Because more amount of the binder content over there, aggregate to aggregate content is broken, and then it is going to become weaker. This is a simple reason. After drawing this, we have to study our reference point, and that our reference point is 3.6%. This is. With this 3.6%, we will draw a line, as I have drawn over here. From this line, we are moving parallel to the x-axis. It is going to touch at this point. So keep this thing in mind. This is the point of intersection of the curve. This is the point of intersection along the y-axis. Please repeat again. With respect to this point, where PB is equal to 3.63%, we are moved parallel to the y-axis. It is going to touch the curve, cut the curve. From this point of intersection, we are moving parallel to the x-axis where it touched to the y-axis. That point is being studied. That point is the value of stability. And this value comes out to be 1880 kgf. Please repeat, let me repeat it again. The value taken from the graph is 1880. With reference or with respect to PB is equal to 3.63. Now the question arises that is it acceptable? Please mark my word. The question arises, is it acceptable? Just the question mark over here. Then this value coming from the data taken from the graph, is it acceptable? Now we will search out its solution. How will we search out the solution? Because we will go to the technical specification of the project. Our technical specification says that minimum value required is 1100 kilogram into force. And our value 1880 is far greater than 1100. Mark my word. This 1880 is far greater than 1100. So this thing shows that with respect to this binder content, whatever the value of stability we have calculated, it is acceptable to us. It means why it is acceptable? Because it has satisfied the requirement of the limit set in the technical specification of the project. It was just brief introduction which I have to give you. If you still need some further clarification about this, please write down your comments and I will try to explain it more good way. Thank you for seeing this.